TTL Computer 2. Today we'll be taking a look at an overview of the selected flash hardware for our flash storage file system. And as you can see here, I've decided to go with a compact flash solution. And that's opposed to, basically have two main choices here, is compact flash being one, it's an older technology, and then SD card flash, which is predominantly used by everything today, but there's some reasons why we went with compact flash. And if we look here to some of the system features, um, we can see that the primary reason we went with compact flash is because it has a true IDE compatibility mode. And that means that we can use this flash card uh, as using the same interface, 8-bit interface that the early IDE hard drives used and the early computers used. So that's going to be a really good solution for us with TTL Computer 2. And that basically allows us to do operates with an 8-bit data bus. And again, that's what we have with TTL Computer 2. So that's a big plus with the compact flash. Now, another feature that I guess is desirable in the card is it can operate in 5 volts and 3.3 volt uh, power supply. That unfortunately is going to cause us a problem because of our soft start power supply that we have, where our power supply is going to provide something less than 4 volts for about 200 milliseconds and then switch to 5 volt. So that is going to be likely cause an issue and may cause the compact flash to operate in 3.3 volt operating mode. And we don't want that. That will not work with our computer. So we're going to have to address this issue in our hardware design, but we won't be concerned with that today. Okay, so looking at compact flash supports a lot of different capacities of flash drive, and we're going to go with 32 megabytes. And we introduced the concept of LBA in the last two videos of our file system, or logical block address. And the logical block address, um, identifies one storage unit in the flash card, and the unit of storage for the flash card is 512 bytes. So one logical block is 512 bytes, and that's the minimum we can read and write to the flash card. So again, we have to take care of those complexities, I guess, at our software level. But so we're going with 32 megabytes, so we can see that the maximum logical block address for 32 megabytes is 62,720, and that is can be represented in 16-bit address space, which is TTL Computer 2 is a 16-bit address space. So this is very convenient for us that we can address the full 32 megabyte flash storage card with our 16-bit address. Okay. Now, so how is TTL Computer going to communicate and operate with the flash card? And this is going to be much the same as what we saw with our UART. The flash card provides 8 registers 0 through 7, that TTL Computer 2 can use to interact and operate with the flash card. So read and write to the different registers. And these will be mapped into addresses 2040 through 2047. So very similarly to what we did with our serial UART, the communication and the mapping into our address space is going to be very similar to that. Okay. Now we're going to be using this compact flash adapter to IDE, right? So we know that we selected the compact flash primarily because it supports the true IDE mode. And uh, that again, that IDE mode is the essentially the 8-bit uh, the 8-bit uh, data standard that the fixed disk hard drives used for the early computers. So the true IDE mode is signal compatible with IDE, but is not pin compatible. So this adapter is going to do a couple things for us. So first and foremost, it's going to do the pin. It's going to do the pin make this be pin compatible from compact flash to IDE. So it's going to route the pins where they need to go. Uh, the second thing that it does is that the compact flash enables true IDE mode by bringing a certain pin low. So the adapter card is going to do that for us. So the adapter card is going to make that be pin compatible with IDE, put it into the true IDE mode, and that's pretty much what it does for us. This is mostly a dumb card. But the other thing that's going to do is that you can see this part here. This is the compact flash socket, and this pretty much all of the compact flash sockets look like this. And the pins are very small, and it's a surface mount. It's a surface mount socket. So I don't do that kind of, I don't do surface mount solder work. So that's the second thing that this card does for us. It allows us to get, you know, a standard, pin header socket that we can plug into our board that we're going to build, our flashcard board, and it also puts it into true IDE mode. So since we're not really building a flash storage card, we're building an IDE interface card because that's what the compact flash does for us, and that's what this adapter card does for us. So we're really designing uh, a 40-pin IDE interface, which means technically we could plug a standard, IDE hard drive into our interface card, and that theoretically would work. Okay, so that is what we're doing. That's the hardware we've selected to use, and the interface that we'll be building is an IDE interface to the compact flash card. So I think that's it for today. In our next video, we will be looking at our IDE interface, our compact flash interface in our digital simulation to see if we can get that working. And that's going to be our next stop in our build. So until next time, that's it. Thanks for watching.